Good morning, dear students. My name is Ferhan Mazher, and today is 12th of March 2022. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. Today, we have set our hearts to solve a theory paper. We call it paper 2, and we have selected October-November 2015 to paper. In this session, in this video, we are going to attempt the section A of this paper. The section B of this paper we will solve in another session, in another video, and I will upload that as well. So today we are going to solve the section A of this paper. So let's start today's paper. So here we go. October, November 2015 to paper. It's paper 2. The time allowed is 1 hour 45 minutes. So section A we are going to attempt today. So water is transported to a village in a tank pulled by a tractor. Figure 1.1 shows the tank being pulled by a tractor. So here you have a tractor, and this is that tanker, and that tanker contains water. The combined mass of the tractor and the tank is 41,000 kg. 4,100 kg. When the tank is empty, and 6,500 kg when the tank is full of water. So when the tank is empty, the total mass is 4,100 kg, and when it is full of water, the mass is 6,500 kg. The density of the water is 1,000 kg per meter cube. Calculate calculate the volume of the water in the tank when it is full. So first of all, let's find out what is the mass of the water. So from the loaded tanker minus the empty tanker's mass, you will get the mass of the water. You know the density of the water, so very easily density is mass divided by volume. So the volume will be mass divided by density. So let me show you how this is done. So we know that the mass of the water will be 6,500 minus 4,100, 2,400 kg. So the mass of the water is 2,400 kg. You know the density is mass divided by volume. So the volume will be mass divided by density. So mass is 2,400 kg and the density of the water is 1,000 kg per meter cube. So 2,400 divided by 1,000, that will be 2.4 meter cube. So hopefully you understand. And let me show you the marking scheme as well. Okay, so here we have the marking scheme. So our answer to 2.4 meter cube, the answer is right. Okay, so let's move to the next question. And he says, at the start of the journey, the tractor and the tank accelerates from rest along a straight horizontal road. As the speed increases, one form of energy is decreasing. State the name of the form of the energy that is decreasing. Because the tractor uses fuel, and the fuel has the chemical potential energy. As the tractor will be going on, it will be accelerating. You know, the fuel is combusted, it's being burnt, and the when the fuel is used, obviously the chemical potential energy is decreasing. The fuel has the chemical potential energy, and that is gradually decreasing. So the answer will be chemical potential energy. Then he says, explain what happens to this energy. You see, in the engine of the tractor, the fuel is burnt, so that chemical potential energy converts into heat energy, and that heat energy is then converted into the kinetic energy, some sound energy, and some heat. And so let me show you my answer. Here we go. So the chemical potential energy, and as the fuel burns, chemical potential energy converts into thermal energy convert into kinetic energy, sound energy, and some heat. Hopefully you understand. Let's have a look at the marking scheme. So fuel, chemical potential energy, some to heat, thermal energy, some to kinetic energy of the air or the tractor. Okay, so this is what you have to write. So that was the B part. Now we are coming to the C part. The village is located on a mountain at a vertical height of 850 meter above the water supply. The gravitational field strength G is 10 Newton per kg. Calculate the gravitational potential energy gained by the water as it is transported from the supply to the village. So the gain in the gravitational potential energy, the formula is mgh, and we will use the mass of the water because mgh, because the we have to find out the gain by the water, the gravitational potential energy gained by the water. So mgh, so 2400 kg multiply 10 Newton per kg multiply 850 meter. So you just enter these values in your calculator, you get 204,000,000 joules. And so the final answer will be 2.04 expo 7 joules. So let's have a look at the marking scheme. What the marking scheme says, 2 expo 7 joules is the right answer. So our answers are right. So we are done with the question number 1. So let's move to the next question. The next question coming up on your screen is question number 2. The surface of a running track is made of rubber. A heavy trolley is pulled onto the track and it exerts a large force on the rubber track. State two effects that this force has on the rubber. So when you move a heavy trolley on a rubber track, so due to the weight of the trolley and the moving of the track of the trolley on the track, 2 3 things can happen. The shape of the rubber will change, the rubber will compress, you can say the temperature of the rubber will increase. So these are the few things which can happen. So let me show you my answer. Question number 2, A part, rubber will be compressed and the temperature of the rubber will increase. So let's have a look at the marking scheme. It says any two from different lines of distort, stretch, change in the shape, squeeze, bend, deforms, compresses, change in the size, volume, density, depth, height, change in temperature, gets hotter, generates heat. So hopefully you understand. So next question, B part. He says a spring is suspended from a support with a small pan attached to its lower end. Masses are added to the pan until the spring is extended well beyond the limit of proportionality. So figure 2.1 shows this apparatus. So we have put so much mass here so that it has crossed the limit of proportionality. So their question is, a ruler is used when determining the extension of the spring. On the figure 2.2, sketch the extension load graph for the spring and label the limit of proportionality. So because you have crossed the limit of proportionality, at the start, the graph between the extension and the load will be a straight line, and because the extension and the load will be directly proportional to each other. But once you have crossed the limit of proportionality, the graph will be no more a straight line. It will become a curve, and that will curve and it will bend upward. So as you can see, I have shown on the diagram up to the point where the extension load graph is a straight line. I put a dot and I have labeled it as P, and beyond that point, the graph is no more a straight line. It has become a curve. So this point P is the limit of proportionality. Then the next question they are asking you is that says the masses are then removed and the extension of the spring decreases. State suggests what is observed when all the masses are removed. You see, because you have crossed the limit of proportionality, so when you will remove all the masses, the spring will not come back to its original length. Now, when you have removed all the masses, the length of the spring will be no more equals to the original unstretched length of the spring. It will be little longer than that length because you have crossed the limit of proportionality. So even though you have removed all the masses, the spring will not come back to its original length now. The length of the spring will be more than its unstretched length. So hopefully you understand. So that was the question number 2. So there will be a permanent extension. Okay, any two forms, different lines, distort, stretch, change in shape. We're done with that. Straight line from origin upward curve, labeled clear from the limit of proportionality. We are right. Our graph shape was perfect. Permanent extension or spring is longer than it was originally. I hope you understand question number 2. Let's move to the next question. Okay, so the next question on your screen, he says a very deep tank is used when training sailors to escape from submarines. The tank is cylindrical and open to the air at the top, shown. Figure 3.1 shows the tank. So here you have that sailor, this is water, this is base, 32-meter deep tank. Okay. So the area of the base of the tank is 45 meters square, and the tank is filled with the water to a depth of 32 meter. The density of the water is, he says, the density of the water is 1000 kg per meter cube, and the gravitational field strength G is 10 Newton per kg. Calculate the pressure due to the water on the base of the tank. So if you want to calculate the pressure of the water, the formula is very famous and very easy. Pressure is equals to rho GH. The pressure is equals to rho GH. So the rho is 1000, the G is 10, and the depth of the water is 32 meter. So just enter these values in your calculator. You will get 320,000 Pascal. So it will be 3.2 expo 5 Pascal. So let's check the marking scheme. 3.2 expo 5 Pascal. Our answer is right. Okay, so the next thing they are asking is the pressure in the water at the base of the tank is 4.2 expo 5 Pascal. And this is more than the value which we just calculated, the pressure due to the water. Explain why the pressure in the water at the base of the tank differs from the value calculated in the A part. In the A part, we only calculated the pressure which is due to the water, due to the weight of the water. But in reality, the pressure at the base of the tank will be due to the weight of the water plus due to the atmospheric pressure. So that's why our value was less than the actual value of the pressure. So let me show you my written answer. So the base of the tank is subject to the pressure of the water as well as the pressure of the atmosphere. Okay, so the next question they are asking is, he says, calculate the pressure exerted on the base of the tank. We know the pressure of the total pressure on the base of the tank, and we know the area of the base of the tank. So we can calculate the force exerted on the base of the tank. You know, the pressure is equals to force divided by area. So force will be equals to pressure multiply area. So it will be 4.2 expo 5 multiply 45. So your answer will be 1.89 expo 7 Newton. So when you round it off to two significant figures, it will be 1.9 expo 7 Newton. So let's have a look at the marking scheme. 1.9 expo 7 Newton. 1.9 expo 7 Newton is the right answer. Okay, so the next part is force is a vector quantity and pressure is a scalar quantity. State how a vector quantity differs from a scalar quantity. Vector quantities have direction as well as magnitude, whereas the scalar quantities only have magnitude. They don't have direction. So that was my answer. So let me show you the written answer. My written answer, question number 2. Vector has direction, whereas the scalars have no direction. Hopefully you understand. So let's have a look at the marking scheme. He says vector has a direction or scalar does not have a direction, or vectors may cancel or scalars cannot cancel. Okay. So the question number 4, we are going to the question number 4. Okay. Here we have a copper saucepan with a wooden handle, contains cold water. The saucepan is placed on a red hot heating element that is a part of an electric cooker. Figure 4.1 shows the saucepan on the heating element. So here you have the saucepan, you have water in it. This is the wooden handle. So here you have the heating element. He says, explain why wood is suitable material for the handle of the saucepan. You see, the wood is a bad conductor of heat. so the handle will not get hot and it will not burn your hand. So let me show you my answer. So it says wood is bad conductor of heat, handle will not get hot. So, okay. So wood is a poor or not a conductor or a good insulator. The next question they are asking is describe and explain in terms of free electrons how thermal energy is transferred through the copper base of the saucepan. You see, in terms of electrons, we have to explain this thing. The the metal sauce, the base is of copper, is made of the copper, which is a metal, and it has free electrons. So the free electrons at the hot end, they will absorb the heat energy and they will move faster and they will go to the cold end. And at the cold end, these free electrons will collide with the atoms of the copper and they will make them vibrate vigorously. In this way, the free electrons from the hot end take the energy and they go to the cold end and they provide the energy there. So they transfer the energy there. This is called free electron diffusion. So let me show you my written answer and then we will have a look at the marking scheme. The free electrons at the hot end absorb energy and they move to cold end. There, these free electrons collide with the atoms of the metal. Energy is transferred from electrons to the atoms of the metal at the cold end. And in this way, the heat is transferred. Let's have a look at the this process is called free electron diffusion. So vibrating atoms, ions, particles, molecules, electrons gain energy. Atom, ions, particles, molecules hit free electrons or electrons travel a long distance through the copper saucepan. Electrons hit transfer energy to distant atoms, ions, molecules, particles. These are the 3 marks. Okay, so let's look at the next part. Second part, it says describe and explain how the thermal energy is transferred upward through the water. You see the water at the bottom absorbs the heat and the water molecules move away from each other and the water becomes less dense and hot. This less dense and hot water rises upward, so the cold and the dense water from the top sinks downward. This sets up convection currents in the water, and by the help of these convection currents, you see the heat is transferred throughout the water. A very famous question. This is. And water at the bottom absorb energy. Water molecules move away from each other. Water becomes hot and less dense. Less dense water rises upward. Cold, dense water sinks down. This sets up convection currents in water, and heat is distributed throughout the water. Hopefully, you understand this answer and you never forget this answer. Okay, so let's have a look at the marking scheme. He says, hot heated water expands, is less dense. Hot heated water, less dense. Water rises, sets up circulation, or you can say convection currents, or cold water sinks. So I have written here a word convectional. It's not the word convectional, it's convection currents. Okay, so make this mistake correct. This is not convectional, it's convection currents. So hopefully you understand. Okay, so keep this change. Okay, so here we go to the next part. He says, all thermometers use the value of a physical property to measure temperature. State what makes a physical property suitable for the measurement of temperature. We always use that property of that physical property, which changes uniformly with the change in the temperature. So let me show you my answer. Okay, so the physical property should change uniformly with change in temperature. So let me show you the marking scheme. It shows, okay, the property varies with the temperature. Okay, so next question is, he says, state 2 properties that are used for the measurement of the temperature. There are different properties. lot of properties which changes with the temperature, and we use them to make thermometers. For example, the volume of the mercury. For example, the pressure of a fixed mass of a gas. For example, the resistance of a wire. For example, the EMF induced. So these are the some property. For example, the color of the liquid crystals or crystals, you can say. These are the some properties. You only have to name two. And let's say I've just named volume of a liquid and the pressure of a gas. They can be used to make thermometers. So let me show you from the marking scheme. It says any two from the volume of the gas or density or a length of a thread of the liquid, voltage or current or EMF, resistance, pressure of gas, color, quantity of radiation emitted, and liquid crystal structure. Okay, so the next question, next part, I mean, when thermometer is calibrated, two fixed points are used. One fixed point is the ice point. State what is meant by the ice point. Ice point is basically the temperature at which the ice starts to melt. Or you can say the ice point is the temperature at which the ice and the water mixture coexist. So let me show you my answer. Let me show you. Okay, ice point is temperature of melting ice, the temperature at which the mixture of solid and liquid water is present. Okay, so let's have a look at the marking scheme. Oh, this is the marking scheme showing up on your screen. Hopefully you understand. It says, explain how the fixed points are used when calibrating a thermometer. So you see, whenever you want to calibrate a thermometer, we hang the thermometer in we put the bulb of thermometer in the melting ice, and when the level of the mercury in the thermometer becomes steady, you mark a mark which shows the level of the mercury, and that mark is known as the ice point. And then we hang the thermometer in the steam of the boiling water, and obviously the thread of the mercury will rise up, and when the thread of the mercury becomes steady, so coinciding with the level of the mercury, we mark a point on the thermometer, and we call it the steam point. And then we divide the distance between the ice point and the steam point on the thermometer into 100 equal parts, and that is how you calibrate a thermometer. So let me show you my written answer. So put the thermometer in melting ice, mark the level of the mercury on thermometer. It is ice point. Put the thermometer in the boiling water's steam, mark the level of the mercury. It is steam point. Divide the distance between ice point and the steam point into 100 equal parts. So this is how you will calibrate a thermometer. Okay, so let's have a look at the marking scheme. He says, immerse the thermometer in the melting ice at the ice point or the boiling water at the steam point, or the ice point and steam point marked found may be employed. Divide the difference into 100 units or sections. So this is how you do your question number 5. I hope you understand. Okay, so now question number 6 is coming up on your screen. He says a gas is trapped at atmospheric pressure in a cylinder by a piston. The piston is held in a fixed position by a movable rod. Figure 6.1 shows the rod. So here this rod is stopping from this piston from moving. The cylinder is heated. As the temperature of the gas increases, its pressure increases. Explain in terms of molecules why the pressure of the trapped gas increases. You see, the volume of this gas cannot be changed, and you have started heating it. So what will happen? The kinetic energy of the molecules of the gas will increase. So the gas molecules will move faster. So they have more kinetic energy, and they are moving faster. Their collision frequency with the walls of the container will increase. Now, because the collision frequency has increased, the number of molecules colliding per unit area of the walls in per unit time, that will increase. And now the molecules, because they have more kinetic energy and they are moving faster, now this time when they hit the walls of the container, they will be hitting harder. they will be exerting more force when they collide with the walls of the container. So that's why the pressure per unit area exerted by the gas molecules will increase. So the pressure of the gas will increase. Let me show you my written answer. Gas molecules start moving faster. Their kinetic energy increases. Their collision frequency with walls increases. They hit harder on colliding with walls. Larger force exerted on per unit area. So that's the reason the pressure will increase. So let's have a look at the marking scheme, and here we go. They or the molecules move or collide faster or gain kinetic energy. The molecules collide with the walls more often or harder. The next thing they are asking is, okay, he says the rod is pulled down and the piston is then free to move as shown in the figure 6.2. So when you have pulled that rod down, so that piston is free to move, so that piston will move to the left and this gas will expand. He says the temperature do not change, but the gas has expanded. So state and explain in terms of molecules. What happened to the pressure of the gas? Because when the gas will expand, so the number of molecules per unit volume that will decrease. So the collision frequency with the molecules with the walls of the container that will decrease. So the pressure exerted by the gas will decrease. So let me show you my written answer. So here we go. Gas molecules per unit volume decreases, collision frequency of the gas molecules with walls decreases. So molecules colliding on per unit area, per unit time of the walls decreases. So the pressure will decrease. So this is my written answer. So let's have a look at the marking scheme. It's very important to always check your answers with the marking scheme. So the pressure decreases, larger volume of gas or the molecules move further between collisions, fewer collisions per unit time, reduce collision frequency or molecules with the walls or collide less often or pressure decreases or to atmospheric pressure. Okay. So that was the question number 6. I think next is question number 7. Light enters a parallel sided glass block at A. The angle between the side of the block and the ray of light in air is 35 degrees. The light then strikes the edge of the block at the B. Figure 7.1 shows the ray of light and the glass block. So the angle of refraction in the glass at A is 33 degrees. He says calculate the refractive index of the light in the glass. Okay. So this is the angle of incidence will be this one. It will be 90 minus 35. You can find the angle of incidence. And this is the angle of refraction, that's 33. So I can find the refractive index. The refractive index is represented with N. So the formula is N is equals to sine I divided by sine R. Sine I divided by sine. It's a 2 marks numerical. So let me show you. So the I and the angle of incidence will be 90 minus 35. It will be 55. N is equals to sine I by sine R. So N is equals to sine 55 divided by sine 33. And that will be 1.5. So the refractive index of the glass is 1.5. 1.5 is the right answer, ma'am. The light undergoes total internal reflection at the B state. One condition necessary for the total internal reflection to occur, the angle of incidence in the dense medium must be more than the critical angle of the glass. So, or the medium, the dense medium. Angle of incidence in the dense medium should be more than the critical angle. So that's our answer. Okay, so our answer is right. Next thing they are asking is On the figure 7.1, continue to the ray to show the path of the light after the total internal reflection at the B and until it leaves the block. So let me show you. Here we go. So this angle of incidence, which is more than critical, the angle of reflection will be equals to this angle of incidence. So this blue light will come here. So when this angle of incidence is less than the critical, so the light will emerge into the air because it's traveling in a dense medium and it will emerge into the rare medium. It will bend away from the normal. Hopefully you understand. Let me show you the marking scheme. Reflected ray in correct direction by to edge of the block and no second TIR. Okay, so our answer is right. Question number 8 coming up on your screen. A spotlight in a television studio is at full brightness. The lamp inside the spotlight is powered by a 230-volt supply and the current in the filament of the lamp is 27 amperes. Calculate the power of the lamp. The power, the formula, very famous formula, power is equals to IV. Just put the value of the I, 27 ampere, V is 230 volt, and you can calculate the power. So power is equals to IV, 27 multiplied 230, you get 6210 watts, so it's approximately 6200 watt. Hopefully you understand 6200 watt. Let's check the marking scheme. 6200 watt is the right answer, sir. Then it says the spotlight is kept switched on at full brightness. Calculate the energy transferred by the lamp in 30 minutes. You know the energy is equals to IVT. The energy is equals to IVT. The I value is given, the V value is given, the T is 30 minutes, but we don't take the time in minutes, we take the time in seconds. So 30 multiply 60. So the IVT 27 multiply 230 multiply 30 multiply 60. So your final answer will be 1.1 expo 7 joules. So let's have a look at the marking scheme. 1.1 expo 7 joules. 1.1 expo 7 joules is the right answer, sir. Okay, so then he says the cost of using 1 kilowatt hour of electricity is 23 cents. Calculate the cost of using the spotlight for 30 minutes. If you want to calculate the cost, and if you want to calculate the cost, the formula is power multiplied time multiplied price. And the power should be taken in the kilowatts and the time should be taken in hours. And we can calculate the cost. So 6210 divided by 1000 multiply 30 divided by 60 multiply 23. So you get 71.4 cents, which is approximately 71 cents. So divided with 100, you get $0.71. $0.71 is the cost. Let's have a look at the marking scheme. And it is $0.71. So our answer is right. So my dear students, today we have done October, November 2015 to section A. The section B of this paper we will do in another session, in another video. I have tried my best to explain you the first 8 questions of this paper. I hope this video will help you. If you think that this video is helping you to improve your concepts of physics, if you think that this video is helping you to do the past paper practice of physics by sitting at your home, by looking at the YouTube video, please share the link of this video onto your Facebook accounts, into your Instagram accounts, into your Google Classrooms. It's a great blessing for me to be helpful to you. So, my dear students, have a good day. Thank you very much. God bless you all.